Okay guys, listen up. This is one of our last machine safety demos we're going to do. We're going to be talking about the drill press today. Alright, how many of you have used a drill press before? Right, if you've got any kind of machinery in your garage, it's likely that maybe a drill press is one of those things. Very useful machine. Obviously we're going to be making holes. It's a drill press and it's designed for drilling. So first thing I want to talk about are really quickly a few parts of this machine. Okay, a base down on the floor. We have a table here which moves side to side so you can adjust for your position. It also adjusts up and down with the rack and pinion on the column. We have a chuck here with 3 jaws in it that are going to anchor our drill bit inside there. On-off switch here, motor at the back, and at the top we have a set of pulleys with a belt that allows us to change the speed that this thing turns at. Question: why do we need to have this thing adjustable to change speeds? What's the big deal with changing speeds? Drill bit size, right? Tell me about that. Why is that a big deal? Good. A larger drill bit has to turn slower. So what happens is, if I've got a very small drill bit like this, if you can imagine the amount of distance that this drill bit travels as it makes one rotation is relatively a short distance, or it's a pretty small amount, right? If I compare that with, say, this drill bit here that is cutting this much actual traveled distance as it makes one rotation, there's way more distance traveled and way more material cut with a large drill bit compared to a small one, right? That means that the cutting speed on this large drill bit would be way faster unless I slow the machine down. So general rule we go by is the larger the drill bit, the slower the drill speed has to be, right? We keep this thing at a relatively slow speed, and it works well for anything around a 3/8 diameter drill bit, sort of give or take. If we're close, that's okay. If we're going to be drilling something exceptionally large or exceptionally small, we can change the speed of the drill bit a bit. But for the most part, we're going to leave it as is. Okay. Quickly, a few different types of drills that we're going to be using. A few different types of drill bits. You guys all probably have recognized this drill bit here. This is a standard twist drill. It has a shank on the bottom, which is going to get clamped by the jaws in the chuck, and it has 2 flutes which wrap all the way up to the tip to allow material to be elevated out of the piece so that it doesn't build up at the bottom. Okay, standard twist drill. This is great for cutting, you know, any kind of metal, wood, things like that. The next kind of drill is this guy here. Anyone know what this type of drill is called? It's fancy. Well, it's not super fancy. This is called a brad point drill. So it's very similar in construction to a regular twist drill. Still has a shank, still has flutes, spiral flutes that go all the way up to the tip. It has a tip in the center, and it has 2 scoring teeth on either side, which give a really nice clean surface in the hole. Okay, so and this drill bit is only meant for drilling wood. All right, so that is a brad point drill. The next one is this guy here. Any guesses to what this might be called? Forstner bit, right? Again, an indexing point in the center to center and locate the drill. Saw teeth around the outside. Sometimes it's just got a knife. These drills also have a shank. They're also a lot shorter typically than other twist drills. Okay? They also don't have flutes on them. So they're not good at drilling deep holes. They come in, you know, they come up to large sizes, so we can drill large diameter, shallow holes typically with these drills. When you're drilling, say, a maybe slightly deeper hole with this drill, what do we have to be careful of or remember to do? Yeah, pull it up frequently, right? Because this drill has no flutes to allow the material to come out of the wood. So what happens is as we drill, material is going to be packing up. Chips are going to pack up behind this drill, and they're going to eventually like plug the machine up. So we're going to just travel down a little bit, mechanically bring the drill bit back up to push the chips out, and then we can go down again, take another ½ an inch deep or so, go down again, that kind of idea. Okay? So there's a Forstner drill bit. The last kind of drill we're going to talk about is this guy right here, and we don't really use these a lot in this class. This is called a spade drill. It's commonly used more in construction, electricians, plumbers, things like that, for drilling holes through studs, for wiring or conduit, stuff like that. Similar in idea to a brad point drill in that it's got these two scoring cutters and a point in the middle. Not as clean or as precise as a brad point drill, so we don't use them a lot. All right, let's go ahead and drill a hole. I'm going to drill a hole and show you guys how the brad point drill works, because typically, if we can, in woodwork, this is what we're going to want to use. Okay, so I'm going to open up the chuck, and I'm going to put in my brad point drill bit. We're going to use a chuck key here to tighten up the chuck. Okay, what do I want to make sure and not do with this chuck key? Yeah, exactly. Don't leave it in the chuck. Bad things will happen. I've almost been hit with one of these. It was pretty emotionally scarring, to be honest. I was a grade 8 student early in my career. This thing, someone left it in there, someone turned the drill press on, it came flying out and smoked the wall right, like whizzed by my ear and smoked the wall right beside where I was standing. So these particular chuck keys actually have a little spring-loaded pin, so they're actually very difficult to, like, they kind of want to push out on their own, which is great. It's a good safety feature. Make sure these stay right on the shelf there. Okay, so we have our drill bit tightened up nicely into our chuck. Now we're going to mark out on our board where we're going to drill a hole. Okay, so let's say I want a hole right here. Is that good enough to mark it in pencil? No. I also want to use either a center punch, or to be honest, even another drill bit. Okay, I just want to give that thing a little actual physical detent where the drill bit will be located. Okay, just to help guide the drill bit into that location. The reason for that is, especially if we're using a fairly small drill bit, these things bend and they're not always perfectly straight. So the tip of the drill as we turn this thing on sometimes does a little, like it wobbles a little. We want to make sure that the hole ends up exactly where I actually want the hole. So that little mark that we made in there with the tip of a drill bit or center punch is going to help guide the drill and make sure that I get the hole exactly where I want it. Okay? We're going to clamp stock all the time in here. We're always going to use a clamp. It's safer and it's more accurate. Okay? So we're going to use this parallel jaw clamp here, and we're going to tighten this just a little bit to start with. And I'm going to bring the drill bit down, making sure that it's falling right into that location where I want it. And I'm going to go ahead and tighten up. There we go. Now we're ready to go. Why do I have to use a backing board underneath this table, or underneath my project?
So you don't drill into the table?
So I don't drill into the table? Yep, that's a very good answer. There's also another reason. What happens when the drill bit goes through the bottom of my board here? If there was... Right, it's going to break out. So if I don't have a nice clean board underneath to fully support the wood that's on the back side of this piece that I'm drilling into, it's going to splinter and blow out the bottom. So if we want a nice clean exit hole on the back side of this, we need to make sure and have a nice clean backer board underneath there. Okay, we're ready to go. So I'm going to make sure it closes. that. Safety stuff, I need glasses, making sure that I have hair tied back, no loose clothing, things like that. Here we go. So turn the machine on, and nice and slow and smooth. Just bring that down. There we go. Okay, wait for the machine to stop, and now I can take my piece out, and I've got a very nice 1/2 inch diameter hole with no blowout on the back. Pretty slick, eh? One more feature I want to talk real quick about this drill press is this guy right on the side here. This is a depth stop. Okay, so it's a threaded rod, and it has 2 nuts on it, and this allows the drill to only go as far as the depth stop is set. Okay, so for what reasons might I want to use that feature? So I don't drill into the table? Yeah, that could be. Basically, it's if I want to drill holes of a very specific depth, right? Or if I want to drill a whole series of holes all the same depth. That's another really useful feature for that depth stop there, or a useful purpose for that. Okay? Follow those rules, and this is a very safe machine to use. Bottom line. Any questions? No? That's it?